Hello everyone. Today I will tell you how to prove the integration of square root of a square minus x square dx equals xy2 square root of a square minus x square plus a square y2 sine inverse xya plus c. There are two methods to find its value. First one is by parts and second is substitution method. I will discuss one by one. First method is method 1, by parts method. By parts. As we know that in by parts we have two functions, say u and v. Say u is the first function and v is the second function. Say this is first function and this is second function. And we know by parts concept is first function as it is, integration of second minus differentiation of first function, integration of second function, and whole integration. This is whole integration. So here we will take, let it is I equals the square root of a square minus x square dx integration. And we can write it as integration of square root of a square minus x square into 1 dx. Because we need two functions, only then we can apply by parts method. Say this is first function and this is second function. Say this is first and this is second. So using by parts method, we can write I equals first function as it is, integration of second, first function as it is into integration of second, minus differentiation of first function into integration of second function and its whole integration. Here we can find out this will remain as it is, and integration of 1 would be x minus differentiation of square root of a square minus x square would be 1 upon 2 square root of a square minus x square into, applying chain rule, minus 2x into integration of 1 would be x and dx. 2 will cancel out over here and it would be x into square root of a square minus x square minus x square upon square root of a square minus x square dx. Now we have minus x square minus a square. In the next step, what we will do, we will add and subtract a square in this. Say I equals, this first term will remain as it is, minus adding a square and subtracting a square. On adding and subtracting, x square root of a square minus x square minus, we can write it as taking these two together, a square minus x square upon square root of a square minus x square will become only under root a square minus x square. It will be square root of a square minus x square. Then minus minus plus a square and dx upon square root of a square minus x square. Minus minus plus or a square will remain as it is, dx upon a square minus, and this will be dx. Now this is I again. A square minus x square dx is I. We can write I and plus I equals x square root of a square minus x square plus a square and dx upon This will be 2i equals x square root of a square minus x square plus integration. Integration of square root of a square minus x square dx upon square root of a square minus x square. We know that it is sine inverse x upon a plus c. It will become I equals xy2, dividing both sides by 2. It would be, say this is c1, a square by 2 sine inverse xya plus c1 upon 2, that is new constant c. Hence we have got that integration of a square minus x square is equal to xy2 a square minus x square plus a square y2 sine inverse xya plus c. This we have done using by parts method. Now we have second method, substitution method. How to find out its value? Method 2. Second method. Prove that integration of a square minus x square square root dx equals xy2 square root of a square minus x square plus a square y2 sine inverse xya plus c. Using substitution method, we will do it. So how to? Let I equals integration of a square minus x square dx, and substituting let x equals a sine theta. So dx would be a cos theta d theta. A cos theta d theta. Substituting these values here in this equation, say this is 1. We will get integration of a square minus a square sine square theta, because the value of x is a sine theta. X square would be a square sine square theta into dx, that is a cos theta d theta. Taking a square common, it would be 1 minus sine square theta into a cos theta d theta. Square root of a square would be a only. A into a square, and that is square root of 1 minus sine square theta would be cos theta into cos theta as it is d theta. A into square root of a would be a square. Now we have cos square theta, and cos square theta is equal to, we know, 1 plus cos 2 theta upon 2. We can write it as I equals a square upon 2, and separating it 1 upon 2 d theta plus a square upon 2 cos 2 theta d theta. Now we have a square upon 2 d theta only. A square upon 2 d theta, and this is a square upon 2 d theta plus a square upon 2 cos 2 theta d theta. Integration of d theta would be theta only plus a square upon 2. Integration of cos 2 theta would be sine 2 theta upon 2. So we have a square upon 2 theta plus a square upon 4, and we can split. So we have a square upon 2 theta plus a square upon 4 sine 2 theta equals 2 sine theta cos theta plus c. a square upon 2 theta. We can substitute the value of theta from here. It would be x upon a. It would be x upon a. From here, we can find out the value of theta. We can write x upon a equals sine theta. That is theta equals sine inverse a. Substitute the value of theta over here. This will cancel out. 2 upon 4, that is a square upon 2. Sine theta is x upon a. And using the identity of cos theta, that is 1 minus sine square theta. And sine theta is x upon a. It would be a square upon 2 sine inverse x upon a plus a will cancel out. A will cancel out. A will cancel out and you will get a square, that is ax upon 2, and taking LCM, a square minus x square upon a square plus c. On solving, you will get a square upon 2 sine inverse x by a plus take square root of a square would be a only, and a will cancel out. So you will get x by 2 under root a square minus x square plus c. So by substitution method, we have calculated the integration of a square minus x square square root, and it is a square upon 2 sine inverse x by a plus x by 2 square root of a square minus x square plus c. That's all. Thank you so much.